Hello, this is section 2.4, and we're talking about linear inequalities. So we're going to solve linear inequalities and applications and solve absolute value inequalities and applications. Now we're going to do a little warm up. We have equations and inequalities here, and we're going to look at if they have one or more solutions, and we're going to draw the solutions on a number line. Um, so first, we're going to need a number line here. Um, 0 in the middle, and then we're going to go towards the negatives also. Now, x equals 2, so that means that the only solution for this one is 2, so it will be a closed, which is a shaded in dot. Now, our next one is x is greater than or equal to 2. Um, Now, the line under here means the equal. So it is again going to be a closed, so a circled in dot. Um, the inequality sign is greater than, which if you look at the sign, it's pointing towards the right. So yes, we are going towards the right because that's where the greater numbers are, 3, 4, and so on. Now, sometimes, actually, yeah, sometimes you might also see instead of the dot, you might see brackets here. That's another way of doing it. The dot is, I guess, more usual, but there are some um, sometimes you'll see that bracket also. Okay, let's move on to the next one, which is x is greater than 2. So what is the difference between this one and the previous one? We don't have that equal sign. It is only x is greater than 2. So that is when we draw the open circle and still going towards the larger numbers, so 3, 4, and so on. Now, instead of that open circle, you might see, again, parentheses drawn. So that's another option. So when you have the equal sign, the line under the inequality sign, that is when it's closed and it is a shaded in dot. When it's you don't have it, it's marked with a circle. Okay, so those were greater than or less than. Now let's look at or greater than. Sorry, those two were greater than and equal to or and greater than. Now we're gonna go to less than. So x is less than or equal to 2. Again, we have the equal to, so it is going to be a closed. And um, the arrow is pointing towards the left, so the smaller numbers, 1, 0, and so on. Okay, next one doesn't have the equal sign again. It's just x is less than. Um, so that's again a circle. And less than means that we are going to the left. Okay, those were pretty straightforward. Now we actually have inequalities here. Well, those were inequalities as well. But now, if you look at this one, we um, have to do some calculations to it before we can graph the inequality. So what we need to do is we need to isolate the x. So 8 times x, there's a multiplication between the 8 and x. So we're going to do the opposite operation of multiplication, which is division. So we're going to divide both sides by 8. Um, those cancel out, and we end up with x is less than or equal to 4. Okay, so let's graph that one. 2, 3, and 4, and we've got our negative side over here. So we're going to start with 4. It is equal to, so we are um, drawing a dot, and then less than is going to the left again. Now, it says to describe using interval notation. What that means is that we're going to write a shorter version instead of, or another way, instead of the x is less than or equal to 4. So our interval notation for this one would be, so it keeps going and going to the left. So we are going to start from negative infinity. And that is going to be marked with parentheses. Infinity and negative infinity are always marked with parentheses. Next, we're going to go put a comma and then all the way to where this stops. Well, it stops at 4. And 4 is included, so it is going to be a bracket on the right side. So this is the interval notation, negative infinity to 4. And again, negative infinity, you have a parentheses because it's not a set number where it stops, and 4 has the bracket because 4 is included. If 4 was not included, it would be a parentheses. Okay, let's look at this next one. We have now negative 8x divided, or not divided, is less than or equal to 32. So we need to divide by negative 8 both sides here. That should not, that should not be, there should be 2 separate like this. Now, one thing you need to remember is that when we are dividing with a negative number, we have to flip the sign. So x is greater than or equal to negative 4. Okay, so let's look at this. We need to start from negative 4, negative 3, negative 2, negative 1, 0, and 1. X is greater than or equal to, so again, it is a dot, and greater than, we're going to the right over here. With the interval notation, we go from left to right. So on our left, it has a negative 4. Negative 4 is included, so we use brackets. And when we go to the right, it's going to keep going and going to infinity. So we're going to mark it as infinity, negative 4 to infinity. Okay, let's move on. So here's the warning that we just did. When dividing by a negative number, flip the inequality sign. Make sure that you remember to do that. Okay, we are moving forward, and now we have a little bit more on the left and the right. So 7x minus 5 is less than 2x plus 10. So what we need to do is isolate the x on one side and the numbers all move to the other side. So we want to move first the 2x to the left. So those cancel out and we end up 7x minus 2x is 5x minus 5 is less than 10. Now we want to move the 5 to the right as well. So we add 5 to both sides. Again, we're doing the opposite operation. 5x is less than 15. We still have the coefficient of x, so the 5 in front of the x. So we're going to divide by 5 now since it's a multiplication. X is less than 3. Okay, so let's graph it. Um, we're going to put a 0, 1, 2, 3, -1, -2, -3. And we start from 3. It is a circle because it doesn't have the equal sign, and it is less than, the arrow is pointing to the left, so we are going to the left towards the smaller numbers. 2 is less than 3, 1 is less than 3, 0 is less than 3. Interval notation for this, again, we start looking at it from the left. So on the left side of what we just draw, the arrow, it keeps going and going. So we have to start from negative infinity, and that is with the parentheses. We end up on the right at number 3, and because it's not included, we're gonna close the parentheses also. Okay, next one. Um, we have a little bit more to solve here. We need to first distribute the negative. So um, this is the same thing as x minus 1 times 3x plus 1 plus 3 is less than or equal to 22. So we don't have the 1. It is a hidden one, um, or an understood one. So there is a 1. And now when we distribute this, um, we just do -1 times 3x, -3x, -1 times 1 is a -1. So the signs flip. We add 3 is less than or equal to 22. Now on the left side, we're going to combine like terms. So we're going to combine x and -3x, which is -2x. And then we'll combine -1 and 3, which is 2. And our next step is to isolate the x. So we're subtracting 2 from both sides. We have -2x is less than or equal to 20. And now we have to move the -2. So we are dividing both sides by -2. And a reminder that when we are dividing, we're flipping the sign. So we get x is greater than or equal to -10. Okay, let's look at it on a number line. So we're going to start with -10 because it is greater than. So we're going to the right. -10 is included. So a dot and then an arrow to the right. When we write the interval notation, we start with the -10 because that's on the left. It is included, so it's a bracket. And we're going to the right all the way to infinity. Infinity, again, is parentheses. So negative infinity and infinity are always parentheses. Okay, let's look at the next one. Find all values of x for which the given products will at least break even. Remember from, I believe it was 2.2, where we talked about the break even. So we have our cost function and we have our revenue function right here. So break even was when the cost function equals the revenue function. So C equals R. So what we're going to do is we're going to set these to be equal. So 50x plus 6,000 equals 65x. Now, again, same thing. We want to isolate the x And now, usually we move everything to the left. Right now, I'm looking at 50x being smaller than the 65x, so without having to deal with um, negative uh, negative numbers, I'm just going to actually move the x's to the right. So 6,000 equals 15x. And then we divide by 15 and we get 400, or x is 400. Now, this is when it breaks even. Now, notice our question, at least break even. So what does that mean? That means that we want to at least um, have so that the cost and the revenue are equal. Here's the thing though, at least, meaning that the cost is either less than or equal to the revenue. So we just did the calculation. So basically we're plugging in 50x plus 6,000 is less than or equal to 65x. Now, what happens here is that we would do the exact same calculations. This doesn't really change. We just have to be careful with the inequality sign, that which way is it. So if we go through all this, we get 400 is less than or equal to x. So x is greater than or equal to, not 1, 400. So break even was the equal when cost and revenue equal. When it is at least break even, that means that we want the revenue to be higher or the same as the cost. So we use the inequality. And now, again, yes, we get the 400 doesn't change because it is the break even point. We just want the x to be at least 400. So if we write it in interval notation, we start at 400. 400 is the break even point, so it is included with bracket. And then we keep going to infinity um, with on the other side. There's no restrictions on where to stop on that side. Okay, let's look at the next one. So graph the solution and describe using interval notation. So now notice the difference between this and what we've done. Um, Now we have numbers on both sides. So we have 5 is less than x is less than or equal to 10. So let's look at graphing this. Let's start with 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So on the left side here, we have a 5, and it is less than. It is not equal to, so that's going to be a circle. Actually, that's going to be a circle. Now, we are moving to the right, so that the 5 here is the left side. Our right side is at 10, and we can see that we have the equal sign. So the 10 is going to be a dot, and all the numbers in between here are going to be included. So with an interval notation, this would be parentheses 5 to 10 brackets, or bracket. Okay, so this is in between. The x is in between. So our numbers are in between 5 and 10, 10 included. Okay, let's look at this next example where we have 5 is less than or equal to x minus 8 is less than 15. What we need to do first is we need to move this 8 and isolate the x. Now, when we are adding 8 to the middle, we have to add it to the right and we have to add it to the left. So in all those places, that cancels out. 5 plus 8 is 13, is less than or equal to x, is less than, no equal sign. 15 plus 8 is 23. So our x is between um, 13 and 23. So I'm going to start 12, 13, 14, 15, 16. Let's see if this line is long enough. 19, 20, 21, 22, and 23. Um, so 13 is on the left and it is included. So that's going to be a dot. We go all the way to the right to 23. That is not included, so it will be a circle, and it's all the numbers in between these numbers. So interval notation, 13 is included, so a bracket. 13, 23 is not included, so close it with a parentheses. Okay, next one here. We have 7 is less than 3x plus 1 is less than or equal to 22. Same thing here. We need to subtract 1 from all the different sides of the inequality sign to keep it equal, balanced, equal. So 7 minus 1 is 6, is less than 3x, is less than or equal to 21. Now we have that 3 as a coefficient, so 3 times x. We again do the opposite to move the 3, so divide all 3 again by the 3. So 6 divided by 3 is 2, is less than x, is less than or equal to 7. So we got rid of, or we isolated the x in the middle. So we can draw a number line here. 2, 3, 4, 5, 6, 7, 8. And graphing it on the number line, 2 is not included, so it's going to be an open circle. 7 is included, so shading it in. And all the numbers in between. As interval notation, we start on the left with a 2 that is not included, so it's parentheses 2. 7 is included, so bracket. Okay, so part 2, absolute value inequalities. First, we're going to look at absolute value as a number. So a reminder, absolute value means the distance from 0. Um, so when we take the absolute value of something, we drop the sign. So I'm just going to draw here a number line. Okay, so when we are looking at absolute value of 3, we're looking at the distance. So here's 3. The distance from 0 is 1, 2, and 3. So our absolute value of 3 is 3. For negative 3, that would be here. The distance from 0, again, is 1, 2, and 3. So our answer is 3. So basically, you just drop the signs. Whatever sign is inside, you just drop it. Okay, absolute value of 0 is just going to be a 0. 0 doesn't have a sign, so it's always a 0. Okay, now we're going to look at a little bit more complicated when the x is inside the absolute value. So if we look at x being inside the absolute value and it equals 3. Now, what we learned from here, we saw that both 3 and -3 equal 3. So our x can be 3 or our x can be -3. Both of those are correct. So now we need to kind of look at this and figure out which way is it actually going. So x, the absolute value of x is greater than 3. So if we think about x is going to be greater than 3, right? So 3 is not included. So our answers are going to be 4, 5, and 6. Those are going to be given values for this. Now, well, what about absolute value of x? When the x is -3. Now, what's going to happen is we're actually going to be going to the other side. So x is less than -3. If you think about plugging in here, absolute value of -4, absolute value of -4 is 4, which is greater than 3 for that one. So we are going towards the greater negative absolute value signs. So -4 is an answer, -5, absolute value of -5 is 5, which is greater than 3, and -6. So for this one, in an interval notation, we would write -infinity. That's where we start on the left. It goes all the way to -infinity. -3, and then this word or, we use a symbol that looks like a U. And then we keep going from 3 to infinity. Okay, so that was absolute value of x is greater than 3. Now we're going to look at absolute value of x is less than 3. So what values are less than 3 here? Well, it's going to be 2, 1, 0, -1. Absolute value of -1 is a 1. Equal equals 1, and that is still less than 3. -2 is still less than 3. But then if we go to -4, that is greater than 3. So we have all the values between -3 and 3. So -3 is less than x is less than 3. And interval notation would be parentheses -3, 2, 3, parentheses closed again, because the 3 is not included in the original problem. So this is how we're going to be now doing this next warm up here um, with the um, yeah, with the inequalities. So this one actually we just did. So you have to choose which one is the correct solution. So x, absolute value of x is greater than 3. Or actually, uh, Yeah, sorry. I got confused myself. So, which provides all solutions to the inequality below? Um, we've got, so what we did was x is less than -3 or x is greater than 3. So the ones that have the solid dots on both sides, those are not going to be our answers. Now, looking at B, it's going from -3 to um, negative infinity. Now, though, it really should be a not a closed, a open circle because 3 is not included. So this part is the one where it's negative infinity to -3. Now, D, again, it should be an open circle and it's going from 3 to infinity. So this is the other part that we've got, 3 to infinity. So actually, we need a combination of B and D as the answer for this one. Our other option, since these are closed circles, would be that we would add the equal sign here, and then it would be a closed circle. Now the -3 and 3 would be inside the bracket. And I think that's what we're going to do here. We're just going to put the equal sign because these are all closed circles. So the same thing um, on here, we got -3 is less than x is less than 3. So as we did the numbers on the graph in the middle here, or in between the -3 and 3, are on the number line, it should look very similar. So looking at B and D again, B is the one that is going from -infinity to 3, and D is going from 3 to infinity. Sorry. No, that is wrong. I am sorry. Of course it's not. It is, it's not supposed to be like that. Okay, let's do this again. So it is in between. I said it here and then I looked at the wrong graph. I apologize. So our graph should be between -3 and 3 and not going outside. So um, this A goes from -3 only to 0. That is not correct. C goes from 0 to 3. That is not correct. E is from -3 to 3, so that one is correct. Again, B and D are the ones that extend to -infinity and infinity. Those are not correct. F looks like that one is correct as well because it's from -3 to 3. So yeah. So the ones that where we have the or, like in this first example, that's where it spreads out away from each other. When we have a combination, like where it's in between the x's, that's when we just draw one line. Okay, let's move on. Absolute value inequalities. So, um, absolute value of x is greater than c. This means that x is less than -c or x is greater than c. So we go from -infinity to -c or c to infinity. Okay? Less than, absolute value of x is less than c. C is a constant. It can be any number here. This is when we have c is less than x is less than c. And it's -c to c inside parentheses. So keep those in mind. And now we're going to go ahead and start solving these inequalities. Um, Now, again, feel free to, pause the video and see if you can solve the inequality on your own, and then continue and look if you got the same answer. Okay, so let's look at m. Absolute value of m is less than 2. Okay, we have a less than, so we're looking at this right here. Um, that means that -2 is less than x is less than 2. When we graph it on the number line, now I'm going to make it a little bit simpler. It's open circles because it is not included, and it's the line between -2 and 2. Interval notation is -2 parentheses, or parentheses open, -2, 2 parentheses closed. Next one is absolute value of r is greater than or equal to 5. We are looking at greater than. So r is less than -5, or r is greater than 5. And equal signs should be on there as well because it is equal to. Number line, here's -5 and here's 5. R is less than -5 or equal to, so we have an equal sign. It spreads to the left. And the same thing, r is greater than or equal to 5. It goes to the right. Our interval notation, we start from the left, parentheses, -infinity to -5, bracket, and then or, which is the u. Again, 5 is included, and to infinity, parentheses, close it. So this interval notation tells us that the numbers between -5 and 5 are not included. They're taken out of it. Okay, next one is absolute value of x plus 3 is greater than 5. Now, we're going to use the exact same thing here that we did. So, but we have x plus 3 is less than -5, or x plus 3 is greater than 5. So before we go any farther, we have to solve. So we have to solve for x, subtract 3 from both sides. X is less than -2. No, not -2, -8. Or same thing here, subtract 3 from both sides. X is greater than 2. So these are our solutions now. We graph a number line where we have our -8 and we have our 2. -8 is not included, so it's a circle. It's x is less than, so it's going to the left. And the same thing with the 2. It's a circle, and we're going to the right. So -infinity to -8, not included, or 2 to infinity. Okay, next one. 3x, absolute value of 3x is less than or equal to 12. So we do the exact same thing with, like we've done with the less than over here. So the -12 is less than or equal to 3x is less than or equal to 12. Again, we have to isolate the 3, so we're going to divide by, or isolate the x. So we have to divide by 3, and we have to divide all of these parts by 3. So -12 divided by 3 is a -4, is less than or equal to x, is less than or equal to 4. Okay, So we have a -4 and we have a 4. Now, -4 is the smallest number here and it is included. So that's where we start. We're going to the right and we stop at 4, which is included. So -4 for inside brackets because both are included. So when it is less than, it's between. When it is greater than, it spreads out away. Um, Now just be careful in case, again, there is like, for example, if this 3x would be a -3x and we would, you know, divide by the negative number, that's when your sign flips again. So got to be kind of watching for that part. Okay, next one. Consider the following equations. Find the solutions if possible and graph on a number line. We already have done the absolute value of x equals 3. So x can be a -3 or x can be a 3, either one. Number line, -3 and 3. Notice that it is equal sign, so there's no, it's just what the 1 point. So if we wrote this in an interval notation, it would be -3 inside brackets or 3 inside brackets. Okay, next one is x, absolute value of x equals 0. 0 does not have a positive or negative sign, so it's going to be just a 0. So on a graph, on a number line, it's just going to be a 0. And your interval notation would be just 0 inside brackets. Again, we have the equal sign here instead of the inequality. Okay, let's look at absolute value of x equals -3. Well, is there a x where the absolute value is a negative? No, there's not. So this is not possible. We cannot have um, an absolute value of a number that's negative. That doesn't, remember, absolute value is a distance. We drop the signs. So it is an empty set is the answer for that one. So a warning, the absolute value of an expression can never be negative. Okay. Oh, I'm sorry. Let me take a sip of water. Okay. Next one. Consider the following inequalities. Do they have one or more than one solution? Draw the solution on a number line. Absolute value of x is greater than -3. Now, notice the difference here. This is an inequality where here um, this was an equal sign. So we cannot have a number that is equal to a negative. Inequality, yes, we can have that. So what this means is that absolute value is larger than a negative number. Um, when we have the absolute value is larger than a negative number, if we think about it, we are going to draw a number line here. We have the infinity and we have negative infinity, um, -3 and 3. Um, can absolute value be greater than -3? Absolute value of a number. If we start thinking about numbers, um, For example, negative 10. Well, if we have negative 10, absolute value of negative 10, this is 10. Well, that is greater than negative 3, right? Same thing if we have an absolute value of 50, that's 50, that is greater than 50. So it doesn't matter how small we go, negative 252, the absolute value of that is 252. It is greater than negative 3, right? So for this one, um, it is true for all real numbers. So any real number um, can be greater than a negative. The absolute value of any real number is greater than a negative number. Okay? Um, Here we have absolute value of x is less than negative 3. So absolute value is smaller than a negative number. Is that possible? If we think about, again, all the options that we did here, all of them were greater than. So this is not possible. So no number is a solution. Your answer is an empty set. And notice an empty set is the like a zero with a line drawn across it. Okay, so let's look at an example here. Solve each inequality, graph each solution, and describe using interval notation. Um, okay, so the first one is absolute value of 5x is greater than or equal to negative 5. What did we just learn? It's greater than a negative. It is going to be all real numbers. So in an interval, I'm touching it. So in an interval notation, it's negative infinity to infinity. Anytime you've got this is greater than or equal to a negative number, sorry. Um, Now, this one is less than a negative number, so that means that it is no solution. An empty set. Okay. All right, let's look at an application. So, the 2007 per capita income for US was $38,611. The accompanying table shows per capita for 2007 for selected states. Now, um, we are going to look at or first we're going to solve the inequality here, um, which is um, so it is a greater than sign. So remember how we did this is greater than. So we have the two that spread out. So is less than the negative number or it is the greater than the negative number. So A minus 38,611 is less than negative 5,000, or A minus 38, not a 6, 38,611 is greater than 5,000. Okay, now we need to solve. So we are adding 38,611 to both sides. And we get A is less than 33,611. Or same thing here, we add 38,611 and we get A is greater than 43,611. Okay, so we got our number, or solve the inequality. Next, we need to graph the solution on a number line. So we have a number line here. And we're going to go ahead and do 33,611. It is not included, so it's somewhere over here. And it's going to the left. And then 70, not 70, 43,611 greater than, so it's going to the right. Now it's asking for which states is this true? So which states are less than 33,611 or greater than 43,611? So 32,404 is less than, so that would be Alabama. Um, Colorado is in between. Georgia, 33,457 is less than, so Georgia is the next one. Iowa is 35,023. That is in between here, so that is not true. Maryland is 46,021, which is greater than 43,000. So that's going to be over here. Missouri is 34,389. Well, that is in between these two numbers. It would be, for example, somewhere here, 34,389. So that is in between. So no. New Jersey is 49,194. So yes, New Jersey is. Ohio is 34,000. So no, that is greater than 33,000 or it's in between those two numbers. Um, South Carolina is 31,013. So that will be one of your answers over here because it is less than the 33,611. Vermont, 36,670 is again in between, which is not included in this area. There's a mistake here. This should be a circle here. Okay, so those were the states that were included. Now, circle the correct phrase that describes um, the states for which the inequality is true. The difference between a state's per capita income and national per capita income is it more or less than 5,000? Now notice the difference. So the difference is more than 5,000 because it is greater than. Okay, let's move on to the next example. Now, look at the difference. We have the exact same numbers for this, but the difference between what we had on this one, it was greater than. Here, now, we have less than. So that's the one that's in between. So negative 5,000 is less than A minus 38,611 is less than 5,000. We're going to add, again, the 38,611 here. These cancel out, and we get the same numbers that we had, but the inequality looks different. So now the It's in between 33,000 and 43,611. Let me move that up a little bit so that it's not. So 33,611, it is a circle, not included, and 43,611, a circle. So it is in between these two this time around. Now, for which states is the income in between? So it's the states that were not um, in example 7. So, for example, 41,042 is in between. So that's Colorado. Iowa is 35,023. That is in between. 34,389 is in between. So Missouri. 34,874 is in between. So Ohio. And 36,670 is in between. So Vermont. So Colorado, Iowa, Missouri, Ohio, and Vermont. So circle the correct phrase that describes the states for which the inequality is true. The difference between a state's per capita income and the national per capita income is more or less than 5,000. Well, if we look at, again, the inequality sign here, it is less than 5,000. Okay, which inequality describes states whose per capita income is relatively close to the national per capita income? Um, where's so it was 38,611. So 38,611 is somewhere here. It actually should be more in the middle. 38,611 is here. So if you look at this one, it is included, like it's in that inequality. So it would be um, this inequality that is less than 5,000. Okay, example 10. The given inequality describes the monthly average high daily temperature T in degrees Fahrenheit in Miami, Florida. What range of temperatures corresponds to the inequality? Verify with a number line. Okay, so absolute value of T minus 83 is less than or equal to 7. It is less than, so when we take off the absolute value signs, we're going to do negative 7 is less than or equal to T minus 83 is less than or equal to 7. We need to add 83 because we have to isolate the T here. And negative 7 plus 83, 83 minus 7 is 76, is less than or equal to T, is less than or equal to 90. 76 is over here and it is included. 90 is included and it is in between. So the range would be 76 to 90. And that makes sense. 83 is in the middle right here. Okay, that's it for lesson 2.4. Let me know if you have any questions. I'm happy to answer any. Thanks. Bye-bye.